Okay, good morning. So we started talking about rational expressions, how to simplify them, how to multiply them, and how to divide them. The interesting part is a little bit more challenging, is how to add or subtract them. Okay, so the only thing that I can do is start by giving you some examples. Okay, so the example starts like this. So I want to simplify the following rational expressions. Example, simplify. Okay, so let me start with a very simple example first. Uh, so I want to have x plus 3 over 2 plus x minus 2 over 3. I want to add these two fractions. It's a rational expression. Its numerator is a polynomial of degree 1. The denominator is a constant, which can be considered as a polynomial of degree 0. So this is a rational expression. It's a rational expression I want to add. By the way, might be this is not the simplest possible scenario. The simplest possible scenario is that I have already the denominators the same. Yes? So if I have the denominators the same, I'm really not, this is not a very big problem. Yes, what I do, I just write the denominators, the common denominator, and then I will start adding the numerators. Yes, so x plus 3 is the 1, sorry. X plus 3 is the 1 on this fraction. So, and then I have plus x minus 2 on this fraction. And then you simplify if possible. So x plus x is 2x, 3 minus 2 is 1, and divided by 2. Can I simplify this 2 with that 2? The answer is no, because this 2 is not a factor of the numerator, so that's the end of the story. Yes. One more thing is that sometimes I want you to also pay attention about if this is a negative sign. Okay, let me just immediately write that one here as well. So let me just change the situation here. I have x plus 3 divided by 2 plus minus x minus 2 divided by 2. If I want to do this, because the denominators are the same, so what I do, I write the same denominator, but x plus 3, but be careful. This minus sign is not only for the first step, means this minus sign goes for the whole numerator. So if you want, let me write it in 2 steps. So that's important. So this minus sign is very important, okay? So what happens? This becomes x plus 3, and then I have minus x plus 2. And then what happens? Divided by 2. So this x and that x are gone. So 3 plus 2 is 5, 5 over 2. So that's also interesting, even though apparently this expression depends on x, but it turns out that the value is always 2.5. regardless of what I choose for x. If I do the calculation, the answer becomes 5 over 2. So my point for this thing is that be careful. If you have a minus sign behind the fraction, this minus sign is not just for the first term coming immediately after that. This minus sign goes for all the numerator. Okay? But of course, things can be much interesting than that. So let us change it to different let me just write x plus 3 divided by 2, but minus x minus 2 divided by 3 this time. Okay, now the denominators are not the same, so my duty is to make the common denominator. So what is the common denominator between 2 and 3? Which it is what? 6. Yeah, 6 is the smallest number which is simultaneously divisible by 2 and 3. So what I do, I would write it like this. I will take 6 here, and I say that 6 divided by 2 is 3 times, I'm rescaling it. 2 has changed to 6 by multiplying it by 3, so I have to multiply the numerator by 3 as well. So what I do is like this. I take the common denominator, divide it in my head by the first denominator. I get an answer. I multiply that answer into the whole numerator. So here the answer is 3, and I multiply 3 into the whole denominator. Sorry, numerator. Then I put a negative sign here because I'm subtracting them, and I do the same process once more. So I divide 6 by 3, it is 2 times. I multiply 2 into the whole numerator, yes? That's it. So this is the only new lesson. After that, everything is as before, because now you have one single rational expression, and hopefully you know how to simplify them. So if I want to simplify that, I expand the numerator, but I will not touch the denominator, okay? So I multiply that, it becomes 3x plus 9, and I multiply minus 2n, so it becomes minus 2x plus 4. And then what happens? So this 3x minus 2x is simply x, 9 plus 4 is 13, and then I have 6 here. So that is the final answer here. Any questions? But of course, if I want to increase the level of the hardness of the problem, then I give you rational expression for which the denominators are not constant, they are also polynomials. That is the most interesting part of our lesson. But I also increase the level gradually, yes? Okay, so what we can do, let me just write another example. So I want to write 1 over a plus 2 plus 1 over a plus 4. Okay, I want to simplify this.
Just quickly ask, what operation was it to find when you compare 2 and 3 in the divisor?
Yes.
Was that the least common divisor?
Or least common multiple.
Least common multiple.
Yes.
Yeah.
Or LCM for short. Well, of course, some books I have seen that they have written least LCD, means least common denominator. But this is, I think, the better one.
Yeah.
Okay, so if you want to do this here, this you have a fraction whose denominator is a polynomial in A. This is also a polynomial in A. So you need to write an algebraic expression which is divisible by that and that simultaneously. And this is the smallest possible expression that you have. So what is that? So can you tell me, do you have some instinct here? So what is the common denominator between these two? You want an algebraic expression so that it is divisible by each one of them simultaneously. Yes?
You multiply them.
Yeah, multiply them here. But this is important to understand. This is not always the correct answer. But here, yes. So the correct answer here is a plus 2 times a plus 4. Okay? So again, you divide this common denominator in your head by the first denominator. You will get a plus 4. You multiply the numerator by a plus 4. So this becomes a plus 4 multiplied by that 1. Then you have addition here, and you repeat the process. You divide this in your head by that one. It becomes a plus 2. You multiply a plus 2 by the numerator of that expression. Yes? Times 1. And of course you expand this. But do you remember, do you think I should also expand this? No, because this is one single rational expression now. Do you remember, if you want to simplify, your goal is to factorize the numerator and denominator. But the denominator is already in the factorized form, so do not multiply it, okay? But the numerator, you should work on it and try to make it as simple as possible. So in this case, if I multiply that in, it becomes a plus 4 plus a plus 2, and then I have a plus 2, a plus 4, yes? So what is the answer in the numerator? It becomes 2a plus 6 divided by a plus 2 times a plus 4. Yes? But you have to be careful. You have to be, it is the case that this is possible to simplify this even more. So this means that, yeah, now you have one rational expression. You need to ask yourself, can I simplify it or not? The denominator is already in the factorized form. In the numerator, I can factorize more, okay? So I take 2 out, it becomes a plus 3, and then I have a plus 2, a plus 4. Yes? Can I simplify something? No. So that is the end of the problem. I myself prefer, when I realize nothing can be simplified, I will remove the pairs of brackets, but that's up to you. If you want, you can just stop here. In this case, if you stop here, that's okay. Because even after factorization, nothing can be cancelled out. So in that case, even if you stop here, that is okay, because you can say that I foresee this, that this cannot happen, that I can simplify any factors anymore. Okay, so my preference is not, when I realize nothing can be simplified, I will write it without pairs of brackets. Okay, so this becomes this, and then I multiply that. A times A is, this is the common identity, that's common term identity. The sum of these two is 6 times the common term, and then the product of these two. I myself, I told you, I prefer to stop here, but that is sometimes boring, especially if the denominator is a product of a lot of terms. I am also lazy enough not to just do it. I just leave it there, okay? But that in principle, I want you to know. Any questions? So the whole, by my experience, is that the main mistake students actually do is wrong common denominator. Let me just tell you something here. In these two cases, it was a coincidence that LCM was actually the product. For example, if I ask you to calculate 2 over 3, so let me write 2 over 6 and then plus 5 over 12. Okay, if I ask you to add them, of course you can multiply them, and that would be 72, and then use 72 for adding them. Yes, it is possible. 72 divided by 6 12 times, you multiply 12 here, it becomes 24. 72 divided by 12 6 times, you multiply 6 by 5, it becomes 30, and then you add them, it becomes 54 divided by 72. And then, of course, if you stop here, that's not complete, because you can simplify that, and then you divide everything, for example, by 18, it becomes 3 over 4. Yes? But it is not the optimized way to do it. It doesn't matter if it comes to small numbers like this, but in algebra, this is the price that you pay is actually too much, because sometimes it is extremely complicated if you want to follow this rule. But technically it works, but not efficient. The efficient way of doing it is to take the common denominator to be 12, because 12 is the smallest number which is divisible by 6 and 12. Of course, 72 is also simultaneously divisible by 2, but that's not the optimized way of doing it. So if I take 12, then I would say 12 divided by 6 is 2 times 2 times 2 is 4, and 12 divided by 12 1 times that is 5. And it becomes 9 over 12. So instead of working with bigger numbers, I work with smaller numbers, and then I simplify it again by 3, it becomes 3 over 4. So this is what I want you to learn. So this is the source of most errors when it comes to calculations like this. Most of the time, I cannot say most of the time, sometimes the common denominator is indeed the product, but sometimes it is not. I will give you examples, of course. Okay? Any questions so far? Okay. Yes?
Why weren't we supposed to multiply the a plus 2 and a plus 4 together?
No, you are not. I told you.
Yeah, but
If you want, you can stop here
yeah, but
or stop there. I prefer to get rid of pairs of brackets, because usually when you say simplify, you want to get rid of pairs of brackets.
yeah, but you said that we weren't supposed to do it that early on into the equation. Like,
Yeah, we shouldn't do that, because it might happen that after factorizing the numerator, you get something which is in common with the denominator. If you multiply it at this point, then in principle you have to factorize it again to see if it is possible to cancel out or not. So this is why I prefer not to do it until the very last step. Yes? So that's, I want you to see. I will give you examples, it becomes more clear. Okay, let me give you another example. It's also very simple, but let us see how it goes. I want you to, for example, do this. A plus B over A plus B over B. Okay, so what can we do here? So what is the common denominator here? A times B again, you see? And then you divide A times B by A, it becomes B, and then you multiply that B into the whole numerator. And then you have plus, and then repeat the process. You divide this by that, it becomes a, and you multiply a into the whole numerator. Okay? And then you multiply the numerator. So this becomes ab plus b squared plus a squared plus ab, which you simplify, it becomes a squared plus 2ab plus b squared, and then divided by ab. I hope that you realize that nothing can be simplified in that case. Of course, a and b are factors, I agree, but a and b are not the factors for the whole numerator. If you want, of course, you can collect it back, but I would say that I will not do that. If you write like this, that's okay for me as well, but I will stop there because I see that nothing can be simplified again. So this is not mandatory at all. So I will stop there. Okay, now let me start with another example. 2 over x minus 2 minus 4 over x2 minus 4. Okay? This is one of the good examples. Simple, but that probably illuminates what I wanted to talk about this here. So, if you want to solve that, you need to find LCM, the least common multiple of the denominator. So the simplest, the smallest possible algebraic expression or polynomial which is simultaneously divisible by these two. So if you want to start right away and use this trick, it will work, but it will be harder. I will do that later at the end to see what is the differences. What are the differences? So what I do here, because this seems familiar to my eyes, the first thing that I do, I factorize the denominators. I didn't talk about this step because they were already in factorized form. In all the examples that I've brought so far, they're already in a factorized form. But here I have a fraction whose denominator is not still in factorized form. So this is the first step that you have to do. So I will rewrite the first one, but I will factorize the second denominator, which is x minus 2, x plus 2. Okay? Now, can you tell me what is the common denominator between these two? You want a polynomial which is divisible by this, and this is the smallest polynomial possible. Yes? The second one itself. Yeah, that's important to understand this. This is, if you learn this, that's nothing actually very hard going on here. So I would say that this is the common denominator. And then you say that, okay, this, I divide it by that, it becomes x plus 2. I multiply the x plus 2 into the numerator. And then I have a negative sign here. And I divide this by that, which becomes 1. Yes? If I divide this by itself, it becomes 1. And I multiply 1 by the numerator of this one, which is this. Yes? Okay, and then what happens? I multiply this in, so it becomes 2x plus 4 minus 4, and then I have x minus 2, x plus 2, and then I realize that these 4's are cancelled, so it becomes 2x, x minus 2, and x plus 2. Okay, can I simplify something? No. If you stop here, that's okay, but I told you that if this is simple, I prefer to write it back into this original form. But that's up to you. If you want, you can stop. So that is the simplification actually of this expression. Is that clear? But let us try to see what happens if I naively again multiply them. It doesn't mean that it doesn't work. Let us see what are the problems. So if you start just simply multiplying the denominators, then let us see what happens. Then you divide this by the first denominator, it becomes x squared minus 4. You multiply x squared minus 4 by the numerator. And then minus. You divide this in your head by this, it becomes x minus 2. You multiply x minus 2 by the numerator. Yes? And then what happens? I multiply the numerator I told you, you keep the denominator as it is. You multiply this in, so it becomes 2x squared minus 8, and then it becomes minus 4x plus 8. Yes, and then what happens? This and that are gone, so this becomes 2x squared minus 4x divided by x minus 2, x squared minus 4. Okay, so this is also a simple example. You might say that it doesn't matter that much, but yet it matters. If the problem is a little bit hard, you shouldn't make it harder. But this is not the end of the story now, yes? What I'm supposed to do, I have to factorize the numerator. So what is the numerator? Factorization of the numerator, I can pull 2x out. It is x minus 2, and then I have, by the way, I don't need to factorize the second factor. In principle, I should, but I don't need it here, because x minus 2 and x minus 2 are gone, and then what is left for me is 2x, x squared minus 4. So again, you see that you get the correct answer, but in a little bit longer. Okay, and if the problem is actually hard, then you have to care about these little increments of hardness. Yeah, so you should be careful not make the problem harder, because if at each step you want to make it harder, at the end of the day it becomes extremely harder. Okay, so this I don't like it, so don't do that. Okay, so let us go to the next example. Okay, so this example, 2x squared divided by x squared minus y squared minus, and then I will have here x squared plus xy, and the numerator is 2x squared again. You want to simplify this. Okay, if I ask you to simplify this, you immediately realize that the denominators can be factorized more. So the first step is not to find a common denominator, is to factorize each denominator individually. So this becomes 2x squared, and then this is very famous, so this becomes x minus y, x plus y, and then I have minus 2x squared, and then what can I do here? I can factor an x out, so this becomes x plus y. Okay, so do you have any suggestions for me here? What is the most efficient way to do it right away? If I ask you, what is the common denominator right away, what is your answer? What is the common denominator between this fraction and that fraction? Yes?
X plus y? Or
No. X plus y is the greatest common divisor. Yes? You want an expression which is simultaneously divisible by this and that. Yes?
And the first one times x.
The first one times x. Yes? But no. There's one thing left. Because what happens for x plus y? You want an expression. So if you say x, you said x and x plus y. Yes, if I say x and x plus y, I agree with you. This is divisible by that. Why? Because if I divide this proposed answer by that, it becomes 1. That's right. But if I divide your suggestion, which is this one, by the denominator of the first one, I agree that these two are cancelled, but I will be left with a fraction again. You shouldn't be left with a fraction. Yes, so you need to add something to your answer.
I meant x minus y times x plus y times x.
Times x, yes, that's correct. So in this form, if you insist to start right away the common denominator should be x because of that x, and then x minus y because of x minus y, and only one x plus y. Don't think that I have two x plus y's, one here, one there. No, you just need to make sure that what you write here contains all possible factors. So if I want to give you a recipe, you need to write all possible factors that you see with the highest power. So x minus y is a factor so that I see it here, so I write it down. What is the highest power of x minus 1? It appears with power 1 here, but with nothing there. So the highest power is 1. X plus y appears here and there. So I write it down, but I choose the highest power. The highest power here is 1, the power here is 1, the power here is 1, so the highest power is again 1. And then x. X is another factor. It doesn't appear here, but it appears there. So you have to write it down with the highest power. So the highest power is again. So that is your common denominator. That's completely okay if you want to start from here. But if you are a little bit observant, you can make the problem a little bit simpler for you. So what can you do? Can you see that? Yes?
On the second fraction, you can divide.
Yeah, so I mean, this is a fraction. Instead of working with this fraction, I can simplify the fraction on its own and then work with a simpler fraction. Okay, so I myself prefer to do it because I can just eliminate this. But for the future reference, let me just write everything down. So what I do, I will write it like this. And then I simplify 1x from here and 1x from there. I want you to understand this is possible because x's are factors here. So this becomes just simply 2x, x plus y. Instead of calculating this, I prefer to calculate this because first of all, it is simpler. Secondly, it is equal to the previous expression. So now what is the common denominator? Can you tell me again? So what will be the common denominator? Do you think this is a good common denominator or not? Yes, it is a common denominator, but it is not the efficient common denominator. Yes, so the efficient common denominator is this one. That's it. And then you divide this in your head by that one, it becomes 1. You multiply 1 by the numerator. You divide this in your, by the way, you put a minus sign here. You divide this by that, it becomes x minus y, and you multiply x minus y into the numerator. And let me simplify this now. So this becomes 2x squared. I multiply this, it becomes minus 2x squared. And then plus 2xy. And then divided by x minus y, x plus y. This one and that one are gone. So what is left is 2xy. I realize nothing can be simplified, so I prefer to put it back. It is not that hard. So this is your final answer. So if you subtract these two algebraic expressions or fractions, you will get this expression. Okay, now mainly I want to increase the level a little bit, but I want you to think about the problem and solve it for me, okay? So I will write one here on the board for you, and I ask you to solve. Is there any question here that you don't understand? Okay, so if I want to tell you algorithmically, the first thing that you do is to factorize the denominators and see if something possible to factorize, to simplify vertically, do it, and then find the common denominator and then continue. But do not multiply the denominator until the very last step if you want to do it. But you need to expand the numerator. After expansion, you need to think, can I factorize the numerator as well? If yes, do it so that it might happen that you can still simplify something from the numerator and the denominator. Yes? Okay, so let me write a problem here for you and wait for you to solve it for me. I start also with simple ones. Okay, x minus 2y divided by xy, and then I have plus 3y minus a divided by ay, and then finally minus 3x minus 2a divided by ax. Yeah, this is very simple first. Okay, I want to wait for you to solve it for me. In the meanwhile, I will continue writing some more here, okay? So let me write this number 1 for you, number 2. Okay, do you have your answer for the first one? Yes, so just, okay. Yeah, Eric?
So I basically did the same as with the and
No, but what is your final answer? Because I don't know the answer myself.
0 divided by x.
What?
Xy.
xy is the denominator. What is the
No,
numerator?
axy.
Axy.
And then 0.
0. Okay. If that is the case, you shouldn't stop here. I don't know, but what is the answer to this? 0. Don't doubt about it, because if you have a fraction whose numerator is 0, you just simply answer 0. Okay? How many of you got 0? Okay, so it's very good. So let us just do that. So you realize exactly what you have to write. By the way, this is a simple example, but when you write axy, it means that you understand what is going on, because if you just blindly multiply them, you will have x squared, y squared, a squared. It will work, but you will make your life much harder. So this is the optimal common denominator, because it contains every factor that you see with the lowest possible term. So let me just try to make you understand. So is it factorized? Yes. So what factors you see? I see 1x, 1y. Is it factorized? Yes. How many factors you see? A and y. But y you have already written with the appropriate power, so you just write a. Okay? And then here you do not have new factors. What is the highest power of a? A appears here and there with the power 1, so the highest power is also 1. X appears here and there with the highest power 1. And y appears here and there with the highest power 1. So that's exactly true. Yes. And then you divide the common denominator that you proposed by the first one. It becomes a times, you multiply a into its own numerator. So this becomes a times x minus 2y. And then you have addition, so you put plus and repeat the process. It's over and over again, so that's something so that the problem is finished. You divide this by that, it becomes x. You multiply x into the numerator, and then the next one is negative, and then you divide this by that, it becomes y. You multiply y into the numerator. Yes? Okay, so if you don't mind, let me clean this and continue here. Okay, so what we are supposed to do, we keep the denominator as it is for the time being, and then I expand the numerator. So I multiply in. So this becomes ax minus 2ay, and then the next one plus 3xy minus xa. And then minus y, I multiply in. So this becomes minus 3yx, but plus 2ya. Yes? And then I start simplifying them. So I have positive ax here, negative xa here, but they are the same and opposite, so they are cancelled. The same story for here and there, and then the same story here and there. So cancellation happening in this way, so it becomes 0 as you mentioned, axy, but this is nothing except 0. So that's also very interesting. So it doesn't matter what values for x, y, and z and a x, y, and a you choose, as far as the denominators are not 0, so you're not allowed to choose 0 for x, 0 for y, 0 for a. But if you respect this, then this is always 0, regardless of what value you choose for these variables. Okay. Let us see how many of you got the answer to this one. Have you already done that or not? You want? Okay. How many of you have done this? Okay. I will wait a little bit more so that you can, if you have finished here, you can continue. Okay. So what is the answer to this one? Yes?
2 divided by x plus y.
Only it. Okay. So let us check. If you want to do that, what is the first step? The first step is to think if you can factorize the denominator or any denominators here. This is already factorized form, but you already know that you can factorize this. Yes? Have I written the question right again? Yes. So what you do, you just copy and paste the first, but in the exam you need to be patient and write. Of course, when you want to do it on your own, you can do a lot of calculations in your head if you don't want to write. But for the exam, you need to write properly. Okay, so 2xy. The first step, I factorize this using the conjugate rule. Okay, and then you realize that what is the optimal common denominator here? X minus y, x plus y. And then you would say that this one divided by that is x minus 1. I multiply it by the numerator, which is 1. So when I multiply it, it becomes this. But then I have a negative sign, which you have to be careful. If you divide this by x minus y, you get x plus y. You multiply x plus y by the numerator. But if you write like this, it becomes wrong. Yes? So you have to put the pair of brackets. And then this one divided by that is just 1, and then you multiply it by its own numerator, so the answer becomes simply that. And then you just keep the denominator for the time being like this, and then you expand. So it becomes x minus y minus x minus y plus 2xy. And then what happens here? So this one and that one are gone. You have 2xy minus 2y divided by x minus y, x plus y. So this is the reason that I told you do not multiply the denominator until the very end, because now you can see that, can we simplify something? Yes or no? We cannot simplify. So what did you say as the answer? Am I wrong somewhere?
Oh. Wait, and Anakin has so many problems.
You have done something wrong.
Okay, let us see what, because this is not what you
No,
got. X minus y minus x plus y plus 2xy. Apparently not.
I had Baba.
Yes?
On the third fraction on the top, the beginning.
Yes?
It was in the beginning 2x, not 2x.
Aha, okay, thank you. So this is a new problem, you mean? So the original problem I wrote was this one for you, sorry. So this is 2x. And then this will also be 2x. This will also be 2x, thank you. And then what happens?
Last one is
It becomes 2x minus 2y. So it becomes 2x minus 2y. Okay, and then what happens? You can see that in the numerator I can still factor a 2 out, and then I have x minus y, x plus y. And then this one also is cancelled with that one, so you get 2 over x plus y. So that's the correct answer, yes. So this is why you see it is important not to multiply this immediately. Because if I have done this multiplication from the beginning, then here I have to factorize it again. Okay, so that's also the case. So what about number 3? Anyone? Yes,
the answer is a plus b divided by a minus b.
Okay, a plus b, a minus b. Let us see how it goes. So again, number 3, the first step is to factorize the denominators if possible. And the common denominator here is a minus b, a plus b. So this divided by that is a minus b times, you multiply a minus b into its own numerator, and then you have plus. You do the same thing here, you divide this by that, it becomes a plus b, you multiply it there, and then minus, if you divide this by that, it is just 1, you multiply it into its own numerator. And then you expand, so this becomes a squared minus ab plus ba plus b squared minus 2ab, and then divided by a minus b, a plus b. Okay, the numerator can be simplified more, so this one and that one are gone, so this becomes a squared minus 2ab plus b squared, divided by a minus b, a plus b. But the problem is not finished, because hopefully you can recognize this pattern. This is a minus b to the power of 2, and then you have a minus b times a plus b. Can I simplify something? The answer is yes. One of these and one of them are gone. So as you said exactly, the numerator is a minus b, the denominator is a plus b. Yes? Okay. Tomorrow we will solve the more interesting problems, but at least you understand the concept here. Okay, what about the next problem? So let me just clean this and then ask your opinion about the next one. And I want to put that in GeoGebra as well to see that how we should do that, or what is the correct syntax for asking GeoGebra to simplify. My guess is that you just press the enter and probably it will simplify it for you. Okay, so Rasmus, what is your answer now for number 4? You said
2x squared plus 4a plus 6 divided by a.
so what? There is no x there, but you might mean a, yes?
Oh yeah, sorry.
So
2a squared
2a squared
plus 4a
plus 4a
plus 6
plus 6
divided by a squared minus 1.
a squared minus 1. Okay.
I mean,
It's not complete, I think.
yeah,
Yeah, I think even if this is the case, you can simplify it a little bit more. Yes? So let us check. So anyone answer? Anyone? Yes? Yes?
2a plus
2a?
2a plus 2 divided by a minus 1.
Okay. So this is your, okay. I think this is correct then, but you have to go further, yes? And that's important, by the way. You have to go further. Okay, so what we are supposed to do, we rewrite that so it becomes a plus 8, and then a minus 1, and the next one is a plus 4 divided by a plus 1, and then the numerator, I have 2, 4a plus 1, and then I have a minus 1, a plus 1, because I am supposed to factorize. Now I realize the common denominator is a minus 1, a plus 1, and this one divided by that is a plus 1 times, so I multiply it into its own numerator. And then I have plus, I divide this by that, it becomes a minus 1, I multiply it into the whole numerator. And then here I have a minus sign, but when I divide this by that, it becomes 1. I multiply 1 into its own numerator, it would not change anything. Yes? And then I start simplifying that. I myself prefer to use the identity. So this is the common term identity. If you don't, you can just multiply that. That's up to you. But then it becomes a squared. The sum of these two numbers, 9, times the common term. The product of these two, which is 8. And then I go to the next one. the same story. So this becomes the common term squared. The sum of these two is 3 times a, which is 3a, and the product of these two numbers minus 4. As I told you again, if you forgot about these identities, you can just simply multiply. And then I multiply this, it becomes minus 8a minus 2. And as I told you, do not be in hurry to multiply the denominator back. You just keep it like this. Okay, then you see that I have a squared in common. They are similar, so this becomes 2a squared. And I have 9a, 3a, minus 8a with 4a. And then I have 8 minus 4 minus 2 is plus 2. And then you have a minus 1, a plus 1. Okay, but it is important to realize at least that there is a factor 2 in common, so you can factor it out. A squared plus 2a plus 1, yes, and then divided by a minus 1, a plus 1. And then if you have enough exercise, you immediately realize this is the squaring pattern. So this becomes 2a plus 1 to the power of 2, and then you have a minus 1, a plus 1. And this a plus 1 is a common factor now. So one of them and one, the whole thing in the denominator is gone. So what I'm left is 2a plus 1 divided by a minus 1. And because there is nothing that I can simplify more, I prefer to multiply it back. Let us, by the way, check what is the preference of GeoGebra, how they have programmed that. I don't know, might be GeoGebra provides this answer or that answer, but I myself prefer that one. So 2a plus 2 divided by a minus 1 is the final answer. So I would say this is the first interesting problem. Yes, because you did some simplifications. I mean, it's about a little bit lengthy, but everything actually went smoothly. And then you realize that again, after simplification, you can simplify more by factorizing the numerator. So usually harder problems are of this nature. So if you don't mind, let us also go to GeoGebra to see how this will work here. Okay, so as usual, we go to cast view, and then let us get rid of this view graphics, and then let us type it in. But of course here you need to anticipate when I want to type the first one, a plus 8 is a whole package in the numerator, so even though there are no pairs of brackets there, I know that I have to put pairs of brackets first. And then I write a plus 8, and then I go and divide it. Automatically the pairs of brackets are removed. So be careful about this point when you want to type. And then for the denominator, I don't need to put any pairs of brackets, and then I have plus, the same story. So I open a pair of brackets and then a plus 4, and then I go out and then divide a plus 1, yes, and then I have minus, so I have another pair 2 times another pair of brackets for a. So by the way, I didn't type this multiplication. I hope that it understands. I think if you have one variable, it is safe. You don't need to be worried about putting that sign. So and then you go and then divide by a to the power of 2 minus 1. Yes, so if I haven't typed anything wrong, I hope this is correct. And let us check the answer. I just pressed the enter button. Yeah, that's correct. So, and you see that the preference of GeoGebra is also the same. So even though you can factor a 2 out, but it is not factored out. So 2a plus 2 over a minus 1 is exactly the answer that we got here on the board. Okay. Is there any mistake?
No, but I think I wrote the same thing and got it. No, I did not get it. And that's it. My version, I have the calculator suite, which is slightly different from the GeoGebra Classic.
Yes.
And it simplifies it to 2 times the fraction a plus 1 divided by a minus 1.
So 2 times a plus 1, you mean?
Yeah.
The 2 is factored out, yes?
Yeah. Interesting.
Yeah, I don't know, but usually, I told you that usually if you can remove unnecessary pairs of brackets, it is better to move them. Yeah, but different programs. have different styles probably. But anyway, it shows that we haven't done something wrong, and I didn't do anything. I just typed this and then press enter, so I didn't use any syntax. So it's better to know how it works. Yes.
Do you also know like what version of GeoGebra we will have access to during the test?
I think the 6 is better, of course. I myself was a fan of 5. It was better for me because you usually type it. It's more user friendly, I think, when it comes to 6, and they are updating 6, not 5, probably. Okay, any questions? I think I will stop here and I will continue with exactly the same lesson. So tomorrow I will actually give you more examples so that we can solve together. Of course, the level will be a little bit harder. But this is exactly at the right level for the exam for this. So that is enough if you understand this. But I would prefer to give you a little bit more interesting and more exciting problems tomorrow. Any questions? Okay, thank you.